Hi, I'm Freddie Ortega, and welcome to my Teach Me tutorial for Authoring Tools EDTC 6030. There are four methods used in addressing a network: the MAC address, the IP address, character-based names, and port addresses. We have created four tutorials, each focusing on one of the four methods. During this tutorial, we will focus on the MAC address. At the conclusion of this tutorial, we will be able to identify the MAC address on a network device, describe the anatomy of a MAC address, be able to identify the MAC addresses on a Windows personal computer. So what is a MAC address? A MAC address is a 48-bit address. It is found on every device that connects to a network. For example, a computer has a network interface card, often referred to as a NIC. The MAC address is embedded or etched into the NIC card. Essentially, it is the NIC card or the computer's address. A smartphone is another example of a device that has a MAC address. The MAC address is permanent and does not change. This is how, no matter where one goes, data addressed to the user can always find the smartphone when the user connects to the data, email, or web server. That's right, the data, email, or web server also have a NIC card with an embedded MAC address. In the previous slide, we said the MAC address is a 48-bit address. Let's take a look at the anatomy of a MAC address. MAC is an acronym for Media Access Control. To a computer, it is simply 48 bits or 48 zeros and ones. It looks like this. Imagine trying to write this number down without an error. So for humans, it is displayed in hexadecimal format. It looks like this. Every 4 bits is grouped into 4 bits called a nibble. The binary bits are then converted into decimal notation. But there are only 10 values in decimal, and that is 0 through 9. We use alpha to represent 10, Bravo to represent 11, Charlie to represent 12, Delta to represent 13, Echo to represent 14, and Foxtrot to represent 15. This is hexadecimal notation, or base 16. So let's take a look at a bit value chart to see how these numbers are converted. There are 4-bit positions that have a value from right to left of 1, 2, 4, and 8. If the bit positions are turned off, this is an indication no electricity is present and the nibble has a value of 0 and looks like this. If they are on, electricity is present and the value 1 is shown and looks like this. Thus 4 ones equals 1 plus 2 plus 4 plus 8, which equals 15 in decimal notation or foxtrot in hex.